students. Today we are going to discuss the nature of the two straight lines we obtained from a pair of linear equations from your textbook class 10 and the chapter number 3. We have studied in class 9 that the geometrical representation or graphical representation of a linear equation in two variables is a straight line. Now, what will be the look like of the two lines we get from a pair of linear equations? There may be three possibilities. The two lines can intersect at a point, the two lines can be parallel, or the two lines can be coincident. That is, one is on another line. You have seen in the board that an activity to show the nature of two lines of a pair of linear equations geometrically or graphically. We will discuss this topic by taking an activity, and here for this activity we will be need 3 graph papers, and from this activity we will verify the nature of the two lines and also the comparison of the nature of two lines with the ratios of the coefficients and constants of the two equations. And we know that general form are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Now, nature of the two lines comparing with the ratios, we get this in our book. That is, if a1 by a2 is not equal to b1 by b2, then the two lines intersect at a point. If a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, then the two lines will be parallel. And also, if a1 by a2, b1 by b2, c1 by c2 are equal, then the lines will be coincident. And this we will be observed by taking an activity. Okay, students, to carry out this activity, I have taken 3 pairs of linear equations, and first pair is twice x minus 3y is equal to 3, and the second one x plus y is equal to 4. And now I have taken 3 coordinates points A, B, C, and from the second equation the 3 coordinates are taken as D, E and F. You can choose another coordinate pair also. Now, by plotting A, B, C, this is A point, this is B point, this is C point, and through A, B, C, the straight line we have got. And from the second equation, plotting D, E and F, this is D, this is E and this is F, and through them the second straight line we have got. And we have seen here that two straight lines intersect at a point D or B. And also we do know that when we are asked to solve a pair of linear equations graphically, then we can remember that this intersecting point is the solution of these two these two equations. That is, here the coordinate pair are 3, 1, 3, 1, or you can say this one 3, 1. So x is equal to 3 and y is equal to 1 is the solution of these two equations. And now, if we compare the ratios a1 by a2, b1 by b2 and c1 by c2, we get that a1 by a2, that is 2 by 1, here 2 by 1, that is 2, and b1 by b2, that is minus 3 by 1, that is minus 3 by 1, this is minus 3, and c1 by c2, minus 3 by minus 4, because in standard form here 2x minus 3 by minus 3 will be 0, so minus 3 by minus 4, this is 3 by 4, is it? So a1 by a2, b1 by b2, c1 by c2 we found out. And now second pair of linear equations I have taken 6x plus 10y is equal to 4, 3x plus 5y is equal to minus 11, and from this equation I take three coordinate pairs z, h and I, and plotting z, h, I get this straight line, and plotting j, k, l, this is j, this is k, l, we get this straight line. And here we have seen that two straight lines never intersect at a point, means they are parallel. They are parallel, and since there is no any common point of these two lines, so there will be no solution, and such equations so called as inconsistent equations, means they have no solution, isn't it? And now comparing the ratios a1 by a2, b1 by b2, c1 by c2, we have got a1 by a2, that is 6 by 3, this is 6 by 3, 3 to the 6, so 2, and the b1 by b2 10 by 5, so 10 by 5, 5 to the 10, this is 2, and then after changing it into standard form, this is minus 4 and this is plus 11, so minus 4 by plus 11, that is c1 by c2, minus 4 by 11, that is minus 4 by 11. So we have got three ratios from these two. And now the third pair is x minus 2y is equal to 5, 2x minus 4y is equal to 10. From this equation, these three coordinate pairs are found out, and from this equation, these three coordinate pairs are found out, and plotting them, this is M and T, this is M point, and this is N point, this is T point, and through M and T, we get this straight line. But when we locate these 3 points in the graph paper, we have seen that these 3 points also lie on the same line. And now the ratios we have found out, a1 by a2, that is 1 by 2, this is a1 by a2, 1 by 2, b1 by b2 minus 2 by minus 4, this is minus 2 by minus 4, here we have got 1 by 2, here also we have got 1 by 2. But now, after changing it into standard form, minus 5 by this is minus 10, this is minus 5 by minus 10, again we have got 1 by 2. And we have seen also that there are innumerable common points of these two lines, isn't it? So there will be innumerable solution or many solution of such two equations. Okay, now we are going to make a chart what we have got today. Okay, now we will see our observation from this activity. Here I have taken 5 columns here, nature of two lines, whether they intersect at a point, parallel or coincident, and the 3 ratios a1 by a2, b1 by b2, c1 by c2, and then the observation, the relation of these 3 ratios. At first, from the first pair of linear equation today we have discussed, that is, in the 2 lines intersect at a point, and then we have got a1 by a2, 2, b1 by b2 minus 2, and c1 by c2 3 by 4 from the first pair of linear equation. And so the relation is a1 by a2, b1 by b2 not equal, isn't it? So it is verify that if A1 by A2 is not equal to B1 by B2, then the lines will intersect at a point and there will be a solution then. Okay, and then the two lines we have got from the second pair of linear equation, they parallel, and A1 by A2 we have got there 2, and B1 by B2 2, C1 by C2 minus 4 by 11. So the observation is what? A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, isn't it? So now we can conclude that if A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then we will say that the two lines will be parallel to each other. And then we say that those two equations are incoincident because they have no solution. And now finally, from the third pair of linear equations, the lines are coincident. Means one line is above the other. Okay, coincident. And here the ratios we have got A1 by A2, 1 by 2, B1 by B2, 1 by 2, C1 by C2, 1 by 2 there. That is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So here also we have observed that if A1 by A2 is equal to B1 by B2 is equal to C1 by C2 from the given two equations, then we will say that the two lines will be coincident and the number of solutions then will be many because the two lines are innumerable common points. Okay, so this is our observation and we have verified the ratios with the nature of the two lines. Okay, I think you will try to understand this activity, and also I expect that you also take another 3 coordinates points and plotting them, you also yourself can verify these relations. Okay, thank you to all. You can subscribe my channel. Okay.